today we're looking at 7.3, which is multiplying powers with the same base. Okay? And when we talk about powers with the same base, we're talking about, for example, 3 squared times 3 to the 4th. Okay? The base, of course, is the big number, right? If they have the same base, then you can multiply them. If they do not have the same base, or you cannot make them into the same base, then it's already simplified as far as it can. We'll get to that when we get to it, okay? So here you can use a property of exponents to multiply powers with the same base. So here we're going to look at 3 to the 4th times 3 squared. Now, we're going to come up with a property, okay? So first we're going to look at what 3 to the 4th is. Of course, 3 to the 4th is 3 times 3 times 3 times 3, right? So this is equal to 3 times 3 times 3 times 3. And 3 squared is 3 times 3. So that's times 3 times 3. So if I wanted to write this using exponents, this would be 3 to the 1, 2, 3, 4, 5, 6. Right? 3 to the 6th power. Now, look at what we started with and where we ended up, and observe how did we get from the start to the finish. You added the exponents. Very good. So, when you are multiplying powers, you add the exponents. Okay? So when we show our work, let's see, we're going to have 4 cubed times 4 to the 5th, right? We're going to say 4 to the 3 plus 5. 4 to the 3 plus 5. And that's going to be equal to 4 to the 8th power. And that's it. So on this one, we have b to the 7 plus negative 4. Okay, and this is how I want you to show your work, okay? So, b to the 7 plus negative 4, we get b to the 3rd. So, to multiply powers, and I want you to write down your rule, to multiply powers with the same base, you want to add the exponents. And here is just what we, the examples that we did at the beginning. Okay? Problem 1 is multiplying powers. And we want to know what is each expression written using each base only once. Okay? So here we have 8 to the 3rd times 8 to the 6th. And of course, the way we show our work is we're just going to show that we're adding the exponents. So we have 8 to the 3 plus 6. And that's going to give us 8 to the 9th. Okay? For 5/10 to the negative 3 times 5/10 to the negative 8, same thing. You have 0.5 times negative 3 plus negative 8. So that would give us 0.5 raised to the 8, 9, 10, 11, to the negative 11. Good. All right, so there's letter C. We've got 9 to the negative 3 plus 2 plus 6. Okay, so you just add all of the exponents and then you get 9 to the 5th power. All right, very good. Oh, by the way, for letter B, if they say simplify, would that be simplified, letter B? Why would that not be simplified? No. The exponent is negative, right? So then you would have to flip it. Very good, very good. All right. So, problem 2. Multiplying powers in algebraic expressions. We want to know what is the simplified form. There's simplified. What is the simplified form of each expression? Now, here, what are the exponents connected to?
Just the variable.
Just the x, just the variable. Very good. So, when we do this, we separate the coefficients, okay? Because this says 5 times x to the 4th times x to the 9th times 3 times x. Since everything is multiplication, can't I do it in any order I want to?
Yes.
Yes, you can. Very good. So, we're going to multiply our coefficients first. So we've got 5 times 3 is equal to 15. And then we've got x to the 4th, x to the 9th times x to the first. Very good. So this is going to be x to the 4 plus 9 plus 1. So, simplifying that, we end up with 15x to the 14. Very good. All right, for letter B, again, we're going to multiply the coefficients first. So, we've got negative 4 times 7 times 2. So, what's negative 4 times 7 times 2? Good. So, negative 56. And now we deal with the coefficients. But we've got a C here and a C here, but we've got a D there. Can I put them all together? No. You only put the C's together, you only leave the D together, okay? So we're going to get C to the 3 plus negative 2. We're going to show our work, right? And then D to the second. Oh, because we didn't have to do anything to that. So you're going to show your work by showing what you're adding, right? So our final answer, negative 56. C to the first. Do I have to write a 1 there? No. D squared. So how about letter C? You guys want to do letter C on your own? Okay. So, there, don't forget, it said to simplify, right? So, once you got to the point where you have a negative exponent, you're still not done because you have that negative exponent. You need to flip it. You need to move that to the denominator. So, writing it with all positive exponents, then you are fully simplified. Okay? Now, how about this next question?
Wait, is that how you
I got it.
All right. So, explain how to simplify the expression a to the x times, x to the a times x to the b times x to the c.
Okay.
I never do that.
What do I do, right?
Since you have the same base, you put x, and then a plus b plus c, and then you have.
And since we don't know what the numbers are, you just leave it like that. Good? Everybody clear? All right, problem 3 is multiplying numbers in scientific notation. Make sure you write this down. What is the simplified form of 7 times 10 to the 8 times 4 times 10 to the 5th? Please notice that when I read that, I said times, right? So, since everything is multiplication, can I multiply in any order I want to? Yes, because multiplication has the commutative property as well as the associative property. So, we can multiply in any order we want to. So, I'm going to rewrite this, putting my constants together and putting my powers together. Okay? So I've got 7 times 4 times 10 to the 8th times 10 to the 5th. Okay? So now I've got 7 times 4 is 28 times 10 to the 8 plus 5 is 13. Am I done?
No.
Yeah?
No.
No. Is this scientific notation?
No.
This is not scientific notation. Why?
Because it's not a decimal.
Because the thing didn't get moved over yet.
Because 28 is
Bigger than 10.
greater than 10. Remember, your first factor, somebody said because it's not a decimal. That's not the right answer. The first factor has to be greater than or equal to 1 and less than 10. So, in order to do that, we're going to move our decimal to the right. To the left. And when we move to the left, what do I do to the exponent? What?
Add 1.
You add 1. Very good. So, we end up with 2.8 times 10 to the 14th. Problem 4 is multiplying numbers in scientific notation. You can make a note of what page this is in the textbook, okay? What page is it on? What page? 428. Okay. All right. So, at 20 degrees Celsius, 1 cubic meter of water has a mass of about 9.98 times 10 to the 5th grams. Each gram of water contains about 3.34 times 10 to the 22nd molecules of water. About how many molecules of water does the droplet of water shown below contain? So, we're looking at this number, this droplet of water is 1.13 times 10 to the negative 7 meters cubed. That is the volume of a teeny tiny little droplet of water. Okay? And you know it's teeny tiny because we have a negative exponent, right? And that's going to give me a very, very small number. Okay? So, teeny tiny, this is the volume. We want how many molecules there are. Okay? So we need to change this meters cubed to grams, and then we need to change from grams to molecules. Okay? So this is what we're going to start with. We're going to start with 1.13 times 10 to the negative 7 meters cubed. Okay? So that is how much volume is in this droplet of water. Now, we want to change from cubic meters to grams. So up here in the problem, it tells us that 1 cubic meter of water is about 9.98 times 10 to the 5th grams. Okay? Now, how am I going to place cubic meter in grams so that one thing the cubic meters will cancel? We want to multiply times a fraction so that cubic meters will cancel. So that means 1 cubic meter of water goes on the bottom, in the denominator, and 9.98 times 10 to the 5th grams goes in the numerator. So this is going to be 9.98 times 10 to the 5th grams goes in the numerator. Now look at what happens. What happens when you have meters cubed in the top and meters cubed in the bottom? They cancel out. Very good. So those cancel out. What units do I have left here? Grams, right? You have grams left. So if I multiply this number, it's going to tell me how many grams is in that molecule of water, or that droplet of water, right? But I don't want grams. What do I want? How many molecules, right? Notice in the problem, it says each gram of water contains about 3.34 times 10 to the 22nd molecules of water. So now I can go from grams to molecules by doing the same conversion, right? So we're going to multiply again. And where will I put grams in order to cancel it out? In the numerator or the denominator? Very good. So we've got 1 gram of water is equal to 3.34 times 10 to the 22nd molecules of water. So now grams and grams will cancel. And what's my only unit left? Molecules. So if I multiply all of this, I will have my answer. So let's do it. And I'm going to rewrite it just to clean it up a little bit, okay? So we've got 1.13 times 10 to the negative 7. How if I put parentheses here? Times 9.98 times 10 to the 5th times 3.34 times 10 to the 22nd molecules. Does it look familiar? It's just like problem 3. See? 1.13 times 10 to the negative 7 times 9.98 times 10 to the 5th times 3.34 times 10 to the 22nd. Can I multiply in any order I want to? Yes. Yes. Very good. So, we're going to multiply all of those first. Right? And then we're going to multiply all of those. And then we'll have our answer. So, let's do it. All right. So, we've got 37.6666516 times 10 to the, now I'm going to add my exponents, right? So we've got negative 7 plus 5 plus 22. I'm going to go ahead and round this to 37.7, okay? So we've got 37.7 times 10 to the, what's that? To the 20th. Is that my final answer?
No.
Why?
Greater than 10.
Because this is greater than 10. It's not scientific notation yet, right? So we just need to move our decimal. If I move the decimal to the left one, you add 1 to the exponent, right? So we end up with 3.77 times 10 to the 21st molecules of what?